for his value Ki1. But the output wire of the circuit, if there are equal, is Ri1, which you would learn as Ri1. And otherwise it's Ri0.
What you're saying is that Bob can not know which one of those she got.
Right. So Bob knows what things mean. Alice doesn't know Alice knows what the actual values are, but she doesn't know what things mean. Bob doesn't know what the things are, but he knows what everything means. So that in that way, the information is split between Alice and Bob, where no one of them knows any useful information. The second phase, policy evaluation. So after this step, Alice has some value Ki, which is either Ri0 or Ri1. And we'd like to evaluate this function P of x1 through xn. Note that xi is Ki equaling Ri1. And so we'd like to evaluate this. Now, there's a couple ways one could do this. It's kind of a simplified version. This version here reveals a little bit of information to Alice about Bob's policy. After this, I'll talk about how you can hide that even further. But Bob sends to Alice some encryption with any system, probably something like AES. He encrypts M with the value K. And so knowing M is equivalent to knowing K. But one of the things with scrambled circuit evaluation is that each wire has two encodings. Well, it's convenient that the encodings are already split between Alice and Bob. So we don't need to do an oblivious transfer or anything at this point in time. We can just build the scrambled circuit for the policy. Of course, this does reveal to Alice that Bob's policy can be evaluated with a circuit with the following topology. However, a lot of useful circuits can be built that look the same. So Bob could create kind of a uniform circuit that could evaluate many different types of policies. And Bob will send Alice this scrambled circuit, and Alice at this point can evaluate this circuit. And the output wire, if the policy is satisfied, will be this key value K that Bob has generated. Otherwise, it'll be some garbage value. And when Alice has this K value, she can easily look at this, and if it's the one encoding, she'll get M. Otherwise, she won't. The only real problem with this is that the scrambled circuit does reveal a topology. If Bob's in a situation where even the topology of a circuit is too much information, there is a fairly simple exponential communication system. You can create a single circuit that only consists of one gate with n inputs, and that you can evaluate it with basically order 2 to the n communication. At this point, I'd like to open up for questions. Are there any questions? Yes.
So the correctness, so one of the correctness criterion is that, for example, Alice doesn't learn the access policy of Bob, right?
Right, or the policy is as hidden from Alice as possible.
But like somebody else, gave the example before, she may already know it.
Right.
Just as an example.
Yes.
So then the correctness criterion should be tempered based on that, am I right? It should be something like that perfect secrecy thing where I don't learn anything more or something. Do you see what I'm saying?
Right.
If I already know this, and this, then that's all I know after.
Right.
Basically, I'm wondering if you actually have these correctness criteria stated formally and with the proofs, or is it just...
We have semi-formal proofs that this works. Essentially, we show that if you have perfect implementations of the two phases, that the resulting protocol would be secure. Therefore, if you have a implementation of each of them, you can, using composition theorems, can compose them together. Now, with regards to if they have previous information, basically the method of proof that we use is that if you have a trusted third-party implementation of this, that you can simulate everything that you see in the protocol. So therefore, the protocol doesn't leak anything other than what engaging in the protocol leaks inherently. Because even in the trusted third-party case, some information is leaked, right? because Alice knows with this set of credentials, I know I can get access to this policy or not.
So you're saying it's no worse than if you use a trusted third party?
It's no worse than if you use a trusted third party, which is, a lot of times in secure protocols, is the way that you prove something is secure. Yes?
I have one more general question, which is the following. So, I mean, suppose you have done the negotiation which is successful.
Yeah.
At the end, Alice will access the resource.
Right.
How do we prevent Bob from observing?
Well, the way that we do this in the blinded policy evaluation here was that he sends to her at the beginning EK of M. So, of course, if she doesn't learn K, this doesn't tell her anything, so she doesn't get the message. But the only way that she'd ever get K is if she satisfies the policy. So she kind of gets, at that point in time, Bob won't know because she won't make another request for M to Bob.
But, no, I'm saying, somehow this, you have the assumption that the only thing that she will get is a message M.
Right.
Okay. But what I'm asking is that then she will have to access the real resource, which could be a file or...
Oh, okay. Well, I neglected to mention, the assumption that we're kind of using is that the resource that you're asking is something like a file. It's a one-time resource. It's not a service-based thing. If it's a service-based thing, there's other questions. This could be used to have it so that you can make the access decision, but then there's another question if you have a service. How do you give that service without Bob knowing it if he's giving that service?
So the question was exactly how you combine or how can you use your protocol, maybe extending to that environment as well.
Okay. That's one of the things that's actually kind of open that we've been kind of working on. We don't have a solution for that at this point. Yes?
So I think it was the Holt, Bradshaw, Siemens protocol.
Yes.
Where you said that Alice could learn Bob's access policy because he just uses the identity-based encryption.
Right. That was the original hidden credentials. There's been another hidden credentials paper which kind of does a little bit more complex policies. It has some more types of hiding.
So I was just going to ask, well, what if Bob just asks for a bunch of other garbage? Oh, do you have a driver's license? Are you over 21? All this stuff. But he's actually only going to use...
Right. That is actually supported by our system. But one of the differences between the hidden credentials work and this work was that Alice learns when she satisfies something in Bob's policy. Even if it doesn't get used, she learns that she satisfies something in Bob's policy. Whereas she doesn't learn that in this case. Thank you. Oh.
Now, just trying to get into a completely different part, which is what you were saying about negative credentials.
Yes.
I was thinking about it, and assuming that the issuer of the negative credential is also someone who issues a positive credential that you would otherwise need, you could probably use some sort of integrity measures, digital certificates, to ensure that negative credential is being provided if it exists.
Yes, that is a possibility if the credential authority does more than what it does in this system. Right? The credential authority has to kind of be an enforcer in that case and say, well, you have to use all the things that I gave you, not just one of them.
But I think you can, that should be, there's more to it to get into that, but there are integrity approaches to ensure that if they're providing anything from that credential authority, they're providing everything.
Right. Not sure.
Bertino's done some work.
Yeah, that would be an interesting twist in the system. I haven't considered doing that yet.
That might help with you've kind of built something to allow these negative or non-monotonic. Yes. It would be nice to it would give you a way to make that more.
Well, I guess the other interesting thing is that while the system supports non-monotonic, if everybody used non-monotonic, people would think about things, but if people were just mostly using monotonic policies, you could probably throw a non-monotonic policy in every once in a while without anybody noticing. But still, if I'm not going to use, right, so it's...
Yeah, can I also use that?